I'm fairly convinced that the whole idea of the intro music is to get me to dance, but no one wants that. And like one day I might succumb and you'll all regret it. For the people watching at home, no one put their hands up, and rightfully so. Yeah, exactly. Hello, welcome to ASYNC. Thank you so much for coming. Thank you for anyone watching on the stream as well. We are in May. It is the very first day of May. Happy May Day, everyone. It is astonishingly warm for the 1st of May in England. So I'm very appreciative for you all coming out. And I can guarantee you're not going to regret it. It is going to be a wonderful event tonight. We have James Turner, who's going to be talking about Svelte, who I will bring onto stage very shortly. Sorry, that was like a sort of a stay for a second hand gesture. Sorry, James. I need to work on my hand gestures. This is a public speaking section that I do afterwards. So ASYNC, for those that don't know, for those that it's their first time, this is a meetup that has been going on since 2009, I'm fairly sure, which was when Node.js was first announced and started, because that was the very first ASYNC talk that we had. It is one of the longest running web tech meetups. There is going to come a point at some point soon where one of our regulars is younger than ASYNC. I've just realized this is gonna yeah, it brings me great joy and happiness. And it also makes me feel very old. Anyway, it's so I would like to just give a quick shout out to the venue that we have here. They paid for the pizzas, which were delicious, and I'm extremely grateful for. This is Runway East. This is a fantastic space, beautiful. We are so lucky to have them. So thank you to Runway East. And the drinks that you had at least partly owed by Silicon Brighton. So thank you so much, Silicon Brighton. And people watching on the live stream, all of this, basically everything that you see is Silicon Brighton. We couldn't do this without them. So huge thanks to Silicon Brighton. A couple of points of order. Firstly, we've got a code of conduct. I'm afraid I didn't get the slides together in time, but it's asyncjs.com/code of conduct. It's at the bottom of the web page. The TLDR is just please be lovely to each other, and if you feel uncomfortable, come and talk to me or Jan in the on-brand async purple, which I really should be in. Purple, fuchsia. Somewhere my wife is screaming from Lewis, like, I told you. Anyway, so yes, we have that code of conduct. And are there any other points of order that I've forgotten? I don't think there are, actually. I'm just going to hand it over to Cameron to say a couple of words about Silicon Brighton. Come on up, Cameron.
Thank you very much. Only to add that usually we also mention that the event is live streamed and recorded. So quick show of hands if you don't want to be in the video. Nice, sorted. Oh well. All right, I have done that before, and it does work really well. So not to toot my own horn, but hello. My name's Cameron, as Ali has said, and I work for Silicon Brighton. We're running our first ever conference in Evolve. Silicon Brighton are a digital tech cluster and meetup group. A group of meetup groups. We look after events just like this in loads of different digital tech sectors and lots of different interests. So guaranteed, if you're into digital tech and you're in Brighton or Hove or a little bit further away, you'll find an event for you. This being one of the events, as well as Evolve, which is going to be our giant conference day. It's going to be fantastic. 4th of July. I mean, if you've made it on today and it's that sunny, I think you'll make it on the 4th of July as well to the Brighton Dome. So, we've got someone just over there. But yeah, Evolve's going to be brilliant. There's loads of QR codes everywhere, as well as our Silicon Brighton ones down there. If you want to chat any more about that, get in touch with me. Speaking of those other meetup groups that we support, we've got loads of them. We've got JavaScript as well, which is a monthly drinks that you can get together and talk about lots of things that are probably very relevant to async, I imagine. But yeah, so if you're new, check this out. It's back in the live stream as well, but there'll be a group for you in digital tech. We also support loads of meetup groups, but we also ourselves have loads of supporters of businesses, freelancers, and yeah, giant companies and institutions in Brighton and Hove. It's a really, they're just really generous, and they help us do what we do, which is the live streaming and my time. we want to say huge thank you to our sponsors in James Chase, who are like our supporters, but more continuous in their approach and monthly donations. Huge thanks to Plus Accounting as well, and More Law, who have recently just jumped on us as well, which is fantastic. You can sign up to all of our activity on this link tree, which gives you access to our Slack channels as well. I know there's an ASYNC Slack channel as well, but that is me. So thank you very much, guys.
Brilliant. Cheers, Captain. Yeah. One of my favorite conferences, FFConf, every year. They've been going for what, 16 years, something like that, maybe longer. They say how many people have been to every conference, and so this could be you, could be the one that says that you've been to everyone. Anyway, enough talk from me. James, let's please welcome James Turner to the stage.
I've got this. Hello, everybody. Oh, right. Let's see if we can get that working first. Hello, everybody. So what we're going to be talking about this evening is Svelte runes. So before I start, who's ever used Svelte before? Or anything, any usage of it? So what, 3 or 4 of you? Who's ever used something that uses signals? So something like Solid.js or anything like that under the hood as well? So a couple of you. Okay, right. Lovely. Thank you. So a little bit about who I am. As you can tell from my general lack of hair, I've been doing this for quite a long time. I first started in doing browser stuff probably back in the IE6 days. I worked in the city doing one of the first, this is an FX trading system that was actually doing streaming prices into a browser that you can then trade on. And this was before any frameworks around. And we were doing things like you're in IE6, we were debugging using console statements, and there were no frameworks apart from jQuery that we couldn't use on this anyway. And you were doing things like getting access to the text nodes inside the DOM and sort of pushing updates into it, throttling stuff when prices came down, etc., etc., etc. It was horrible. You have no idea how lucky you are not having to work in that sort of environment. So that's true.
Sorry, James, I'd never usually interrupt so early into a talk. But
oh, yeah, please interrupt anytime you feel like it, by the way.
That's like struck a memory. Like, Kaplan, did you do like micro front ends before micro front ends?
Yes.
Holy crap. What did you call them?
Blades, I think.
Blades. Yeah.
Wow,
that blew my mind. And I thought, yeah, okay, amazing. Kaplan was an amazing system back in the day.
Thank you. So that's what I did in my dim and distant past for my sins. Quick overview of what we're going to do. So a quick look at Svelte, and a gratuitous plug for what I'm doing now, if that's allowed. We're going to do some signal theory. So this is sort of the key sort of conceptual model underlying what we're going to be talking about. We'll then look in specifics for Svelte and see, okay, what some problems that Svelte has got, and hopefully how signals actually fixes those problems. So the new version, so the old version was versions 3 and 4. Svelte 5 came out, and it's also known as Svelte runes. That's got a load of new syntax and quite different. I guess the big difference with Svelte is that what it does is it compiles. So it takes your source code and it compiles it, and then it sends something very different down to the browser. A little more on that later. Once we've done that, we'll have a look at these. So they're looking at making signals, standardizing that and putting it into the language and then into the browsers as well. So we'll have a quick look at that and sort of like what's coming up in the future. And also a little thing about how it compares with React. So it's a very different paradigm to React. So we'll have a little look at that as well. And then actually what I'm going to do is revisit my original question about, would I use runes in the light of the new stuff that's in runes in Svelte. So my gratuitous plug. So actually just when COVID started, I was looking at a number of things. So I was looking at AWS Lambda and doing serverless programming. And basically we wanted to build a demo system, and I wanted to start to use it and see, can I build an entire system using AWS Lambda and programming the back end in JavaScript serverless. And it was also during COVID, so we just set up a side project to do this. My business partner was a member of a cricket club, and we wanted to do some ordering for that. And one of the things that we had to do was we wanted to make it a mobile app. And one of the things, because if you're at the side of a cricket pitch, the signal tends to be not very good on your mobile phone. So we had to make sure that it was as performant as we could get on a mobile. And so looking at things like React, if you download React, you've already got 70K zipped or whatever. And you've got to get that first byte down in one hop of the network when you're going over a mobile network. So I looked at Svelte. I thought, oh yeah, that looks about what I'm looking for. But what it didn't have was the ecosystem around it. So at the time, it didn't support TypeScript, a number of other things that it didn't do, and it just didn't have the tooling. Things like React Query that now is available now, that's now available in Svelte as well. So what's happened over the years is actually Svelte has the ecosystem around it, more people have used it, and it's moved on a lot. So in terms of Orderers, it actually started out just as a side project. It's moving on quite nicely now, and we've got several bits to it. So when the idea is it basically allows people to sell tickets. And there's an administration app where people come along, they set up an event, and these are the tickets, and these are the, you can sort of have various additions to that. You can have offers and stuff like that, timing. And then there's the app itself, and then a QR code scanner too. And that's what we chose to. That's what we use Svelte to do. So now we're going to the next stage. We're having a new self-administration app. So if anybody here is in any organization or stuff that wants to sell tickets, I'm after somebody to come and help beta test. So if anybody wants to come along and do that, then please talk to me afterwards. So that's my little pitch. I hope you don't mind. Okay. So now we'll look at reactive programming. So most of this talk actually comes from a guy called Ray Carniotto, who developed Solid.js and has really been leading the field in bringing signals into JavaScript. There's a link down there. Go to the Dev2 Ryan Solid, and there's a great set of posts that basically explain in a lot more detail what I'm going to go through here. So I really would recommend you do that if you want to get into signals. And to put it simply, in the good old days, that simple statement A equals B plus C, you would basically execute that once, and that's it. And then if you want to change A, you have to execute that statement again with different values of B and C. What we're doing in reactive programming is, rather than making that a once-off statement, we're turning it into a declarative definition of the relationship between A, B, and C. So what that means is you set that up as a relationship, and then if C ever changes, then A will automatically change. So the analogy is it's a bit like a spreadsheet. When the original spreadsheets were developed, they used the signals pattern. So you've got a number of cells, and you've got cells listing on other cells, so that when you change the number in that one, the one in the totals column updates. Now, you only set that up once with your formula in a spreadsheet, but that's the idea. So that's actually the very roots of signals comes from those days. So it dates back to the 60s. So as there's nothing new in the world, it's just now been repurposed into JavaScript and UI work. So what do signals consist of? Well, there are three major parts. So there's some observable state. There's reactions, which is basically what you do when that state changes. And then there are derivations. So we'll look at those. We'll look at those three bits. So observable state. Has anybody heard of something called the observer pattern? That's been around in software for ages. You use it all the time. You add a listener to something, pass it a function, and it gets called back later on. It's as simple as that. That's what the observer pattern is. And you can think of signals as the observer pattern on steroids. So what you're going to do is here you're going to create a signal. And when you create that signal, it's going to give you back two things: an accessor function. So those are functions coming back, count, and a setter. So basically, it's a setter and a getter. Again, nothing hugely complex about that. And you can see there, you've got that log statement. So you log the count that starts off with 0. you set the count to 5, and then once that's been set, so the thing is, once you do that count, that is actually a listener. So this statement is automatically triggered. So you come along and you get that logs coming out. One of the other problems with signals is because it's been developed over different times with different systems, there are lots of different words for the same thing. So you can see signals, observables, atoms, subjects, refs, etc., etc. So you've got lots of different words going out just to keep everybody well and truly confused. So that's the first part. Yeah, we've got a piece of data inside a holder, inside a wrapper object. That's not hugely interesting until we can actually do something with it. So what we're going to do now is call something called a reaction, sometimes known as effects. You know, again, a whole pile of other words to describe what is effectively the same thing. So we've created our signal, and then you can see a bit further down, we're going to create an effect. And what the effect is basically that's something that's going to run when that value changes. So this is, again, this is what we're looking at, A equals B plus C. You change C, and basically the effect is A changes. So you can see that here we go. So we set up an effect. You set count to 5, and then what's going to come out is those log statements are going to come out. And that's going to happen automatically once you set it up. So that's the entire point of signals. You're creating a relationship, and then everything else automatically follows because you've got these observers that are automatically firing and doing stuff for you. The third thing is derivations. So what a derivation is so yes, I should have said on reactions, basically what you're really looking to do there is side effects. So you're going to, so usually in the browser, what you're talking about is you're going to go along and update the DOM or something like that. In that case, you're looking at a console log statement, but you could go and do something else. But the idea of derivations is of reactions is that goes off and does something in the real world. In derivations, what you're doing is you are effectively creating another observable that's combining two others. So here we're doing a simple one. So we're creating, here they use, these examples are from solid.js. So you can think of it as a memoizing. So what you're doing is you're taking the outputs of two observables, of two signals, combining that and creating a third one that has a relationship. And here, in this case, we're just adding the first name to the last name. And then something is coming out. So there you go. So you create an effect there. So once you create that effect, and then if you ever do a change, to that, then what's going to happen is you're going to set the first name, and then once that first name is set, it's then going to print out those log statements automatically because that's all set up. No. This here is nothing to do with Svelte Sol. This actual example, I think, is some solid. But again, I'm trying to make all these names are slightly different. We'll go and look at real Svelte code in a few minutes. So this is nothing to do with Svelte. They actually use separate terms for it as well, as we'll see in a moment. So what then happens is you can start chaining all these derivations together. And so here you can see one where you've just created, in this case, this memo. So you're creating B is A plus 1, C is A plus 1, et cetera, et cetera, et cetera. And what you're going to end up with is, in computer science terms, a directed acyclic graph, where you're not allowed, what that means is it's directed, it's got a direction, and it's acyclic, so it doesn't have any cycles in it. So what you don't want to do is have E updating C, because that then starts to cause loops, and you get all sorts of problems. So things like, that's what used to happen when originally they were used in things like knockout. and it got very difficult to trace where updates were coming from. And when you did something like auto binding, two-way binding, you got these loops starting, and it became absolutely terrible. So what this pattern is a way of enforcing effectively a single way of doing that is controllable, so you don't get what are called glitches, and you get a predictable and consistent state for your set of variables here. And you can do that by, if you just run through these 3 steps. So firstly, you do an update, so you change A. Then the engine will go along and it will run through all the derivations and go all the way through it, do that. And then finally, after all that's settled, then you can come along and run your side effects, and then that's going to go along and update the DOM. Yeah? So that is the fundamental principle of signals. And it's because of this separation and this acyclic mechanism that you don't get the problems that you see with render graphs, and everything is as you'd expect. So that's really the core concept of signals. Does that make sense to everybody? Yeah. Yeah. So exactly. So the underlying library, so solid JS in this case, or in our case, it'll be Svelte, will be doing that. So all you're doing is going, you're saying create signal, create memo. So you're setting up that A plus B equals C, and underneath the hood, it's they're doing all the listening and all the rest of it that you need to do that. Yeah. Who's seen Dr. Dolittle? Do you remember the push me, pull you? Anyway, so if you look back to this diagram and you've got this directed acyclic graph thing, the question is, what do you do? So if A updates, do you then go down through all the thing and then tell all the dependencies? Or you could do it the other way around. You could start off at the bottom and say, okay, what are my dependencies? I'm going to go then and pull. So you've got this definition of push and pull. Actually, what signals does is both. So it pushes and pulls. Thus the push and pull you. So what it does is as it says, when we call this push then pull model, so you update something in the graph and it goes down and all the dependencies, it says, yes, I'm dirty, so I've changed. So you push the notification that something has changed. And then when you actually need to, you can then come along, you go backwards, so you evaluate lazily. So only when you need to. And that becomes important because if those evaluations are expensive, you don't need to do them. And also, because you're in a UI, you might have disconnected a whole set of the graph because you set a filter and said, oh, I'm not displaying that table or something. So you don't need that anymore. So that's that. If you really want to go into the gory details of how this works and the computer science of it, it's there. I'm not about to go through it. Not that I think I could, actually. That's another matter. Okay, that's enough theory. We're going to do a bit of a demo now. So we're going to look at Svelte. We'll see how we had a general definition of reactive programming, of which signals is just one way of doing it. So we'll see that, and Svelte 3 and 4 had used 2 separate mechanisms. Yeah. Yeah. I think what you're saying is that if you lazily compute, you've got to wait for it. Effectively, you've then got to do it, and then you've got to wait for it to happen. Yeah, I think a lot of that's in the guts of the libraries about when it's not necessarily you doing that. Basically, there will be a scheduler inside the library, and this is where you get the variations between how the different libraries work. You get eager and you get lazy evaluation, stuff like that. And again, it's quite it's very gnarly when you start looking inside. Yeah, it depends. When you start looking at different libraries, one might be better for one example, and one might be better for the other. But generally, it means you're doing less work because sometimes you don't need to evaluate it, so you don't want to do work that you don't necessarily want to do. And as that graph changes, as you change variables as well. And we'll have a look at that actually in one of the examples. We can see that in action. Right, okay. I'm going to have to get out of the presentation now for the moment, I'm afraid. Okay. And let's look at some code. Yeah, hang on, I just need to, I need to get another version 4. There we are. Right, so actually I'm going to have to swap between that and the browser. I'm not sure if this is actually going to work very well. Right. Okay, so I'm probably going to need to zoom that up. There we go. So we'll look at some of these issues with Svelte 4. So the first one is we've got some fairly unobvious prop syntax. And I'll just go and look at, hang on. Op props here. Svelte. Yeah, so here we go. So in Svelte, what you
increasing the font size a little bit, smashing Command plus a few times. I think if you hit Command plus, yeah. There you go.
There we go, lovely, thank you.
No worries.
Thank you. So in Svelte, this is a Svelte component. And what you do when you want a component, when you want to pass something into it, what you do is you say export let, and then first name, middle name in that example. So what you're saying is, okay, I'm exporting this thing from this component. We'll go back and look at the parent, and you'll see how that passes data in. And already you can see that we've got this rather strange syntax. So it's fine if you know exactly what you're passing in. But you can see here, if you want to pick up, if you don't want to define each one, then what you have to do is you have to do this strange $$ props thing as well, which is all a bit strange. And then if you then want to pass in some of them, then you can pass in $$ rest props. So you can see that's all a bit weird, when normally what you really want to be using is just normal JavaScript destructuring. You know, so you've got this rather strange syntax to sort of to cope with that. If we go back to the page.svelte, you can see that, sorry about this, this was going to be something else. For some reason, I've chosen Boris Johnson as the name for all of this, and it's going to be all the way through. So there we go. So you can see you're passing a child, first name, middle name, and surname, and you're picking up one of them in that rest parameter. So there's this kind of odd syntax, you know, for passing parameters between components. So that's kind of the first one. It's not hugely related to the what we talked about before, but this one is. So this is inconsistent parameters. So let's look at this one. So here we have some. Now this is the magic of Svelte. So for those of you who've never seen Svelte before, this is where it starts to kick in. So you see that let statement. So what Svelte does is it looks at that, it sees that this is a top level .svelte file. It sees that that let x is used over there, and what it does is it's what instruments that code. So effectively, it's building. If you looked at the code that's actually passed down to the browser, it's created observables on there. And so you can see that what it's doing is let x equals 1. That will just display 1 in there. And you don't have to do anything, and it automatically does all the binding for you. And then we are creating our binding there. So you're saying y equals x times 2. Again, this is actually valid JavaScript syntax known as a label. And that's automatically, so it's looking under there and it's creating a variable called y, and every time x changes, it's automatically updating that. Okay? So if we've got a button there and we hit click, then what's going to happen is that x is going to go to 2, y will go to will go to 4, and those will all render. So that's like, this is why Svelte became popular, because it's a lot easier than doing the same in React, and the amount of code that you need is quite simple. And then you've got a templating thing where you just reference the variables in that. However, even before this, there are some oddities. So you've said there y equals x times 2 and x equals 1, but initially that log will come out as undefined because it won't render this. It only runs this just before it renders. So basically, you know, you've got the JavaScript loop inside your browser. It's actually only going to run these derivations and do that at the end of that loop. So when you start looking, so this is one of the problems in Svelte, you start doing stuff based on variables and it doesn't have in it what you think it is. Right. Oh, sorry. Oh, oh no, it is. Has it just gone? Okay, lovely.
Hop back into Chrome.
Yeah.
Yeah, if you do that, I don't know.
Thank you.
Sorry, stream, you're seeing it all. Oh, your mic's not on, Ali. No, I mute you as and when. Yeah, I'll get
Okay,
back.
lovely. Okay, no problems. Okay. So again, I'm not sure if this is going to work in terms of whether you can actually see anything. But just to actually prove that to you, you can see that initially is undefined, even although we'd set that beneath it. If we then go and do an increment, so before the increment, we can see that x is 1 and y equals 2, which is what we'd expect. But immediately after the increment, x has been changed to 2, but y hasn't been doubled up to 4 yet. So internally, inside those projects, inside there, it's inconsistent. So this is one of the major problems. So if you come along at that point and you go along and you call an API thinking you've called it with one thing and actually you've called it with another. And this is one of the major bugbears with Svelte 3 and 4. Didn't work like that. So yeah, pretty major problem. So it worked for sort of simple things, but then when you started scaling it and you had dependencies, you started to see these, and it ended up being quite difficult to debug. Yeah. It's just the way.
Why is that the case?
You would have to ask the developers of Svelte that question. I think originally, I think they would say they were just trying it out and they're trying out the compilation process and seeing what it would do. Because a lot of this is to do with the fact that it's not looking at runtime activity, it's doing it at compile time, and then it's creating the instrumentation at compile time. I think that's what they'd say, but I couldn't. So that's one. The other thing is you've actually now also, so on top of that, hang on, it's the wrong one, don't want that one. Let's see if I can get back to the other one. Don't want that one either. The other thing is you've actually got 2 ways of doing reactivity. So the first one was called reactive statements, where you just put that strange dollar symbol into your Svelte code. The other way, so this is actually, yeah, sorry, this is another example of the same thing. So we've got in the top one, we've got the let statement. Oh yes, and another little glitch on this as well is that Here, when you're multiplying, we've got this function, multiply by 2. But because it's being compiled, it's looking inside that, it's looking at that line there with the dollar on it, and it's looking for variables, and it's seeing X. And then, so that's why it works. If I actually change it and uncomment those, multiply by hidden, and it's only seeing the X because it's a closure in there, that won't work. So another one of the problems with Svelte is that you can't just take this and take it as a function and then move it somewhere else, because it has to be able to see those variables to be able to instrument it and actually generate the code you want. I can see lots of confused faces, and that's, again, this is one of the big problems with Svelte, is that it was doing a lexical analysis of those files, and if you did things like that, so you couldn't, it was very difficult to just refactor code as you would normally, because you can't just move functions around because the compiler can't see it. So if you wanted to have a store that wasn't inside your Svelte, if you wanted that reactivity, what you had to do is use something called a store. And so you can see here, you've got import count from store. And over here, if we go to here, you can see this thing called. So this is a Svelte store. And you create this thing called a writable. And this is just like a pure observable object there. But you had to put it somewhere else if you wanted to then effectively create global state or state that's shared between different Svelte files. So effectively here we've got 2 separate mechanisms to have reactivity in different parts of the application, depending whether you're in the top level Svelte or whether you're somewhere else. So just another one of the issues with Svelte. And now this is when it gets really gnarly. So what we have here is, even with stores, you can get what's known as glitches. So if you remember, we have our graph of values. And then if you update, say, 2 of them at the same time, so you update the name, or you try to in this case, we try to uppercase the first name and the last name. When you look at the full name, you either want to see both of them uppercase or both of them lowercase. What can happen with stores is, you see, if you get this, there you go. So in here, we have what's called a derivation. So this is, again, this is the equivalent of the $sign on inside the Svelte file. And we're doing const full name equals first name plus last name. And over here, we're toggling the case. So we're doing toggle case. And then it's running the first statement, which is changing the value in the first one. It's then changing the second one to uppercase. Unfortunately, what happens is, because these are 2 totally independent stores, what's happening is it's firing one, changing the value. And then this derived function is firing. And it's going through there, and it's going to show one uppercase and one lowercase. And then the second one's going to fire, and then it's going to show. So you've got this glitched value where you've got lower and uppercase mixed, when actually what you want is either all lowercase or all uppercase. So again, if in there, instead of that being a console log statement, you've gone off and called an API or something, then you've got something very horrible going wrong in your system, and you're going, why is that happening? Okay. So I think I'm actually going to leave that there in terms of what we're going to look at Svelte. For those of you who've never seen Svelte before, does that understand what's happening in terms of this derivations and the fact that it's doing this instrumentation and adding listeners? No. Okay, yeah, actually, yeah.
No, don't worry, don't worry.
You can hum or something fancy. You still could if you wanted to, but it might pick up in the mic.
I'm going to have to remember to press the buttons more often. I think that's the other one. So.
Well, yeah, let them watch.
Right. Okay. So, where are we? Yep. So if we look at the glitchy values, again, if we're going to go and look at the console, and just to prove to you that what I was saying wasn't all entirely made up. So you can see here that we set, remember, we set Boris Johnson to lowercase, which is what he should be. And then we do a toggle. This is the fixed one. Let me do the version 4 one that doesn't work first. Right, there we go. That's better. Right, hang on. I'm gonna have to just inspect. There we go. Console. Clear. Right. Okay. So now let's reload the page. And you can see that, there you go, we've got derived full name Boris Johnson, because those are the initial values, and then we've run that derivation. And then we're going to do toggle case. And you can see that what we've got there is there's that derivation running twice, and we've got that glitched value where we've got the uppercase and the lowercase. So you can see that that's the issue. So let's go to the magic of runes. And you can see here that if we do that toggle case, if I do the right thing and get up that, console, there we go, no glitch values. It's magically fixed it. So, there we go. Weren't you listening? Okay, so shall we go? Let's look at some exceedingly exciting code now. So, how did we do that? So let's go and look at the source, roots. So there we go. So this is the, actually, let's do one mechanism first, shall we? So here we go with our code. So we've got, these are just copying in a couple of children. So we'll see how the parsing goes of variables and stuff. So there is our new way that we do a state. So rather than being called a signal, here it's now just called state, $state. So that's it. So anything that you see with that dollar value like that is a Svelte rune. It's part of the language, and then that is obviously compiled down by the compiler, but that's how it works. So there you go. So you have amount equals $state. And then what we're going to do is we're going to have a derivation on it. Here, then that's another rune. And we go derived.by. The by just means you can stick a function in there. You could have just derived and then just put an expression in there without having the by, but it just makes it, I had it in there just to show there. So you can see that there we are. We're just logging out the value there. And then we're having another one. So what we're doing here is we're typing in a number, and then we're calculating the VAT wrongly by just multiplying by 0.2 rather than 1 plus whatever it is, which I didn't check before I did it. And then in this one, we're showing the show variable. So what we're doing is we're only going to show the VAT if the total amount is above 100. So what this is going to do is showing how you're cutting off bits of the graph as you do that. So that's what we've got there. And then So we're going to pop down through here, and then so there we go. We're just going to do our usual thing now. This is exactly the same. We're showing whether what that flag is. We're showing the amount, and then we've got a child that we're showing the VAT in, and we're passing down. So here you're seeing that we can just pass down one of our state runes directly into the child component, like that. And that's about the important thing. If we go into the amounts of the VAT child, you can see here now that we've got nice destructuring. So we got rid of those dollar props and rest props and all the rest of that malarkey. That's all gone. And then here, what we're doing is you are showing that, dependent on that flag, we're only going to show the VAT if that show VAT thing's there. So we've got that done, like that. And then the other example we've got is this is going to be an effect. So you can see here that this is another rune. So this is the third rune we're seeing. So this is the equivalent of the reaction in the signal theory that we talked about earlier. So we've got an effect. And then what we're going to do is we're going to call canvas and just come along and just write some stuff into a canvas as a side effect. So the interesting thing is actually what Svelte does itself is when it's writing into the DOM, under the covers, it is also using an effect. So you don't need to do it, but effectively that's how it's working. It's using an effect every time it changes and is writing into the DOM. We're doing the same thing here, and obviously you can't do that. So we are having to explicitly write to canvas and write a little bit. Okay. So if we go back to the browser, and go to Runes Solutions. There we go. Prop. There we go. Okay. And let's go and inspect it again. Look at the console. Clear that. Okay, so you can see we've got our two children. You can see that we've got the child, but it's not showing any VAT yet. So if we type in 20, you can see that our canvas is now set, and it's just taken that amount and changed the size of that. So that's all working. That's our side effect. Show is false, and so we're not showing that. You can also see that you've calculated check show and check show, but we haven't calculated the VAT because that's not in our graph yet, because it's not showing, because we've got that if statement that's not showing the component inside the component. So this is an example of us not doing an unnecessary calculation. Okay, so let's get a little bigger. 100. And go 101. Way, there we go. And there's our rounding error. There's our lovely JavaScript rounding error. Doing that. So there you can see that's exactly what's happened. That's gone over, and suddenly we've displayed that in our child component. So hopefully what we'll see over here is, there you go. So it's only now gone and calculated the VAT in the derivation because it only needs to do it now. Yep. How am I doing for time? Yeah, good. Cool. I think we maybe have time for one more then. Which is this one. No, that's the wrong one. Don't want Svelte 4. Runes. Put that in. Oh yeah. So this one we've actually seen before. Seen that one before. So glitchy values. Yeah, so we've seen that before. Oh yes, this is another interesting one. So we're talking now about passing our props into the into children, and what props? I don't need that one anymore. Let's get rid of version 4. Immutable props. Okay. So what we're doing here is we have an amount set in the parent, child, and then what I've got is a function. And so what I'm passing into the child is two things: the amount and a function to increment it. So what happens if you ignore that function that's being passed for the moment? If you do that, what it's going to do is it's going to pass the value into the component, not the actual. So it's effectively what it does is really it passes the getter, but not the updater into there. Now this is what you want. This is like Svelte, like React, is what you want is a tree of components, and you're passing immutable things into it, because what you don't want is the child changing stuff in the parent, because then we get all our nasty loops. So what we're looking for is that unidirectional component and data flow going down through your component tree, just like you have in React. And now that then makes it a lot easier to reason about your application. Yeah, so we've got that. And then if we go into the child component there, what we're doing is you can see that we've got our props that we've destructured. I've got two buttons. One of them is going to increment the child, and then the other one is going to call the function. So you've set the, so effectively you've created a new child state object, and you've populated it with the initial value that's been passed in, and then you've got access to the parent function. So let's see what happens when that actually runs. So if I pass in a number, you can see that that's been passed down and that's been rendered. If I increment the amount, you'll see that what's not changing is what's in the parent. So what we've done is we've changed the child, the one that's in there, and then it's, say, there. Now, if we increment the parent amount, this is calling the function. So this is generally what you don't want to do, but it does work. There we go. So you can see that. So that is that's how it works. So again, there's that much nicer handling of passing props down to components, and you've got destructuring the rest of it. So that's it. So there is a lot more in runes that I'm not going to cover. I'm going to sort of leave it there in terms of the, how runes helps and signals is used underneath the covers inside in Svelte to do all this extra stuff. So I'm going to leave it there. So we'll go back to the presentation now. Where are we? Slideshare. Okay. So if you remember, this is where we left it, and we looked at those 4 improvements that we've got. So we've merged. We've got one reactive mechanism. We've got proper component props now. We've got consistent behavior, and we've got rid of those nasty glitches in derived stores. So it's a lot more consistent behavior. So as I said before, Svelte isn't the only system using signals. Basically, pretty much every other major framework is using it, except the elephant that isn't in this room is React. So I think Solid.js is probably the one that led the field, Ryan Carniato, but lots of the others are using it as well. Vue certainly uses it. And they've all got their different variants on exactly how they use it, and they implement them internally themselves. So that's what's happening. We'll get back to React later, and we'll see the different approaches and the slightly different paradigm on that. So because all these libraries are under the hood using signals, they've kind of all got together and thought, wouldn't it be a good idea if we actually put that into the JavaScript language itself? Then it can be shipped into browsers, et cetera, et cetera. So it's now, TC39 is the JavaScript Standardization Committee. And this is a proposal that's now at stage 1. That basically means it's being seriously considered. It means there's a polyfill available. So if you are that keen, you can download it and you can actually start using it and playing with it. The idea for this mainly is that probably you won't be using it yourself. The idea is that people who are writing libraries are going to be the people using it. So they're all using the same primitives underneath the hood. So that's kind of that I think that's where they're coming from. And most of the people working on all these libraries are all part of that standardization committee. So there's been sort of 10 years of experience using them in the real world, and that's being fed back into the so you can see here, this is the, I mean, this is not finalized. This is just, if you go to that GitHub page, there's a full details on how this works and all the proposals and, you know, the rationale and yada, yada, yada. That's kind of all there. And you can see it's the same kind of ideas. We create a signal.state. We computed, which is our derivation, and we've got effects. And then we're coming along and we are setting, you know, we're then setting stuff on the DOM using an effect. So it's pretty much, it's all the same ideas that we've kind of been covering already. So hopefully this will bring in a load of advantages. That'll be quite nice. So one of them might be that you can actually have different libraries rendering the same model underneath, whether that actually comes to fruition. But you might help interoperability. You might be able to have, you know, solid and, well, probably, obviously it's not going to work with Svelte that's compiled or something like that. But some of the others, maybe Vue and Solid, might be able to, you know, if you've got micro front end and you've got to, you know, you might be able to get those working together, talking about the same library, but talking, you know, with the same set of signals underneath the hood. Might happen. We'll see. You're going to be shipping less code. You know, all those libraries don't have to re-implement effectively the same thing. Might be a bit faster because it'll be baked in. I think probably the biggest win is going to be the dev tools, because trying to get all the traceability and stuff in there, trying to get all the performance of how that's working, I reckon they'll be able to put that instrumentation code into the browser, and that'll make it really much easier to debug what's happening. So I reckon that's probably going to be the big win, I'd hope. And also, they're talking about future HTML enhancements. They're talking about sort of might help in web components, you know, or templating, HTML templating, putting that into the browser as well. So we'll see. This is all future stuff, but you know, it's kind of, I think it hopefully might be a bit of a baseline to go further in the future. React. So what we've seen with signals is kind of what you've got all these little bits of state, and you can get them all to update, and you can get them all to update nice and coherently. And then you can think of your page as just being a sort of set of your HTML with a load of slots that you just come along and you render all the values from your graph into. Now, React takes a very different approach. Now, this is hugely simplified, but roughly, you've got some state. And in this example, all we want to do is disable a button. So you can see over on the far right-hand side, you've got a button, you've clicked a new event, and you want to disable it so you can't click it multiple times. So you update the state inside React. It comes along and it takes you've got the old version of the DOM, which was the VDOM, which is a simplified model of your page. You create another one, you change it. You then do this diffing thing where you come along, you take the two and you work out exactly what the difference is. And then what pops out the other end, you go and update the DOM. So you've gone through all that process just to change an enabled thing on a button. And when the DOM was introduced, it was never to be fast. All it would do was to make React acceptably fast, because it's doing a shed load of work just to do all this to get that update. The reason it did it was actually it makes it easier to think about the application. You've got state, you run a function, you've got the output. So it's almost like doing it on the server side. You've got a database, which is your state, you render a load of HTML, you pass that to the browser. And so if you want to say, why does my why does my browser look like this at the moment? All you have to do is look at the state, look at the function, and that's it. Previously, so this is going back to 2012 and stuff, and I know this because we started trying to use Knockout.js. You know that big application I saw where you have, and we had streaming prices coming in. Those sometimes went stale. There were different price bands. When you clicked, you then had to disable it. I would have 7 or 8 inputs coming in that could disable or enable a button. And we were doing this, and I remember trying to track through a bug. You know, customer said, "Oh, why is that just gone? Why is that button disabled?" And I ended up with sort of 2 sheets of A3 paper, you know, sellotaped together, trying to work out what the reason was and stuff like that. So when React came along, it was yippee da. You know, this is happy days. So, and at the time, it was like Angular 1. So again, anybody who's old time to remember this, they're dirty checking on it. You had Backbone.js, you had Knockout, you got 2-way binding. It was a mess. And so React was a reaction to that and to try and solve that difficulty. The downside, if it's less performant, because you've got all that diffing and all the rest of the malarkey going around. I think the difference now is now you've got signals, you can do these updates in a coherent way that's debuggable. That means you then get the performance advantage of you update the state, you update your tree, but then you don't have to do all the diffing, you don't need the VDOM, that all disappears, and all you have to do is go along and set the enable flag on the button. So it's going to be interesting to see in the future who's going to win. You know, is everything moving in all those other libraries, or is this simplicity, the simpler mental model of React going to win? Who knows? We will find out. That's it. We've reached the last page. You'll be glad to know. You stop listening to me whiffling on. So right back to the beginning, when I first used Svelte, I did it sort of in spite of the developer experience. I did it because it was small and I needed it for a specific thing. Signals, so then went to React because, again, it sort of removes those foot guns that we were talking about. Now, with signals, hopefully we've got rid of those foot guns. And also with Svelte, I think with that compilation, the ergonomics of using signals is going to be a lot better because we've got all that compilation and all the rest of it. You're shipping less code, you're not doing all that virtual DOMing, et cetera, et cetera. You know, as soon as you do that, especially if you're doing it on a mobile phone, you know, not only is there's the memory you're using, there's the battery you're using, there's all the extra bandwidth, et cetera, et cetera. So I think what this is doing is this is swinging the needle sort of away from React and thinking, yeah, I'm now much more likely to use Svelte in an application. I mean, there are other issues like, you know, what are your developers experience out? What tools, what other frameworks are there in the ecosystem that might make you use React, which is still a bigger ecosystem. But I think this has significantly swung the pendulum sort of away from the React and to the other libraries and specifically to Svelte. That's it, everybody. I hope that made sense. Any questions?
Yeah. Any questions? Thanks very much, James. I have questions, but you go on.
I used to have a keyboard that only had a pound symbol.
Some things I can't fix.
I'm trying to think. I have had a few keyboards that haven't had a dollar symbol.
Yeah.
Which would be a little bit awkward. But, yeah.
It is an interesting question, James. Like do you mind saying a little bit more about the label syntax with the dollar syntax? Because I think a lot of people haven't seen that before. Do you know how that works?
It's just a hangover. It's one of those things where you could do, you know, there is a go-to statement. And so you could do a loop, by going, so you basically created a label with a colon on it, and you could break out of a loop and basically went go to wherever. So it's an old, and it's one of the, go-tos considered harmful, so people stopped using it, but it's just a hangover from the original language, and that's it. So it's in quite a lot of other languages, a lot of older languages certainly would have it in it. So it's sitting there, and he looked at it and thought, I'll have some of that. I think.
I didn't know. What's the name of the original Svelte author? Rich Harris.
That's it.
For some reason, I had Hickey in my mind. Okay.
Yeah, he's got lots of good videos out as well. I'd go and search his name and look for a load of videos. He's done some really good ones on runes as well. So yeah, I recommend you go and watch some of those.
So what do you think are the trade-offs and the downsides to the way that Svelte is now doing things?
I think there's still the ecosystem thing. I mean, if I'm thinking which system do I use? I mean, I haven't used runes enough, so I haven't upgraded because I built these ones, and the trade-off was definitely I needed it for mobile. I needed it small. It's really great with some CSS transitions and stuff. It does stuff because of the compilation, and it is a lot less. It is a lot less verbose. It's smaller, so in some ways it's a lot easier. I think the difficulty is this trade-off. I don't know if anybody's heard of Rich Hickey and this idea of simple versus easy. And there are people complaining about Svelte that they don't like this new syntax because there's more lines of code to write, because and it's more difficult to do that. But actually, what it gives you is it makes it easier to understand the code, and that makes it simpler, even although it looks more difficult on the surface. So I think it remains to be seen whether now this makes it as simple as React and whether that mental model is worth it. And it probably depends on what sort of application you're doing. If you're doing something that is fairly sort of CRUD forms and all the rest of it, it is a lot quicker to go and the code's smaller. You're doing some more complicated stuff, then maybe like the trading application, then that traceability. But as the tools improve and all the rest of it, so I think it is I think that the cutover has moved over. How far it's moved, and I don't know. I couldn't give you a definitive answer to that. I'll give you the consultant's answer. It depends.
It's the best answer. I'm going to steal a question if that's okay. I should really know the answer to this. But you mentioned that Preact also incorporates signals.
Yes.
Preact being more or less a drop-in replacement for React.
Yes.
Do you know?
I haven't looked into it in great depth, but I think what it's doing really is what its effect is doing is it's updating the React state.
Right.
What I don't know is whether it's actually hooking then into the rendering innards as well. And I actually haven't really looked in depth at Preact. I think that's my guess, but don't quote me on it.
Okay.
Yeah. Yeah.
Back in the day. Right. Okay.
Yeah. 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 Yeah.
Gotcha.
I haven't followed Preact well enough to answer that question without annoying somebody.
Hi.
I recently converted to Codebase from 4 to 5, and I've been trying to figure out how best to do the two-way data binding, because sometimes you've just got to update stuff in the parent. You can't avoid having that two-way data binding. I was using callback functions. Yeah. I don't know. Do you have
I just had a look at the documentation. There is a bindable rune as well that you can use, and there is because usually you just use bind. And actually, two-way functions, if you're just, two-way binding, if you've just got a simple, I've got an input box and I've got a variable, and it's local to a component, then I think that's fairly safe. But I haven't gone through. I've sort of just I was thinking about upgrading, which is why I did the work for the presentation to work it out.
There's a good script.
There's a good script. Yeah, I've heard about that. But yeah,
there's a few things that are left over.
But
yeah.
Hi. One of the probably main issues I've had working with observable kind of code bases in the past, if I've come into it, is trying to fix an issue, console logging the observable, expecting it to be
Yep,
primitive.
yep, I've been there.
Have you still got the same issues, or the developer tooling? Is the developer tooling there for Svelte or any other signals to help with that?
There is there is an observer thing that you can log. I've forgotten the name of the rune. There is a separate rune. No, there's definitely something in there. I'd have to check the documentation, and it slipped my mind for the moment. But there is something that helps you debugging, and hopefully, once it gets in, and this is hopefully once it gets standardized, that will improve a lot. And again, that was one of the big issues that, you know, using it back in the day, using Knockout, that was the huge problems we had. I mean, it was all trying to work out this, and this was where React scored, where you weren't, you know, these nested observables, and it was just then that's why I was marching off the page, you know, trying to debug that. So I know the pain. Yeah. So I mean, signals help slightly in that rather than just nested observables. But, yeah. And that's where there's that standard pattern of, you know, do the update, run the derivations, you know, so that's with no loopbacks. Yeah.
Thanks.
Cool. Hey, yeah, inspect was that rune, I think, for logging is what you're thinking. Inspect. So yeah, quite a throwback, the Kaplan slide. So back in the day, I strapped on my boots and get it up to the city of London.
Yes.
I was working on a project Zambezi, codename Zambezi at RBS.
Oh, I think I've heard of that.
Yes,
I remember that.
it was known. And yeah, it's really fascinating throwback. Now that little me came to an ASYNC talk back in about 2012, I think it must have been, with Wojciech Gina. And I think I was interviewing like within that week, waltzed in there and impressed everyone with Angular's dirty DOM checking. And so they took me on, and Angular is what we took on to this massive, still don't know the numbers, I didn't understand
Angular
at the time. Angular 1. Now, very interested in, so yeah, I was tasked with bringing that in, and yeah, convincing people twice my age that I knew better. And we were in that transition there where Knockout had blown up for probably the reasons you described. Yeah. Backbone was being picked up, but it wasn't opinionated enough. Yeah. And the nice thing Angular 1 brought in was a lot of opinion for that kind of scale project. I'm curious because I've never known why this concept in Knockout failed, because Signals was obviously the right concept, but somehow at the wrong time. What do we mean by the wrong time there? Why do you think Signals didn't come together, 13 odd years ago?
Well, I think it just took I think it was the lessons from the implementation, and I mean, so it was Signals-like, but I don't think it had that proper separation, and I think that there was the loop, so it wasn't using, from I remember, it was the two-way binding, and then the fact it wasn't a directed acyclic graph, you could have loops in it, and that's when it all went bizarre. So you ended up with all these loops, and also it was all, I seem to remember, it was all within the same tick as well of the loop, so you could go round and round and round and start spinning within the same tick, and then you just carry on with this loop. You could just get a loop of observables. And that was it, and that's, you know, that was the problem I seem to remember having. Again, it was a long time ago, and I kind of like to forget it.
It almost feels like not a decade-long problem in retrospect.
But I think, I mean, this is what a lot of work on Solid.js did. They solved those problems, and that's why using that specific pattern, you know, really helps, I think. But again, we'll see. I mean, I think it's going to depend. The trouble with these things is you only really find these out at a big application when you start to get these complexities and loops in there, and it's an expensive experiment. $inspect is the rune for.
Okay, folks, we're pretty much at time. Does anyone have a burning question? Because James, are you going to come for a quick drink afterwards?
Yeah, I'll take a
fantastic.
Yeah,
so you can come and ply him for any non-burning questions. So yeah, in which case, I think it's time to sign off for the evening. I want to say a huge thanks to Silicon Brighton and to Runway East, and mostly to James Turner. Thanks for coming. So the next ASYNC will be in the first Thursday of June. We're not entirely certain what it's going to be yet. We've got some options. We're playing with them. So so we'll keep an eye on the meetup page, and we will let you know. And then in July, we have Evolve. And so I need to talk with my co-organizers to figure out exactly what the relationship with that there is. But remember, if you do not have your ticket yet, talk to Cameron, scan that QR code. Please do come along. It'll be fantastic. But for now, thank you. And I will see some of you in the pub shortly. Thanks very much.